Zoe, it's about time. What are you up to at InfluxDB?
Yeah, so InfluxDB is a time series database platform. So we're used for storing time series data like what you would commonly find on IoT devices.
Right.
And so right now we are here at the Distributech show showing off for utility providers and just in general people who have a lot of IoT sensor data that they're either looking to store or go beyond with that, beyond the storage, start to analyze and analytics.
So how does the evolution of time series data, how does that play into the whole world of DER and predictive maintenance for the world we're in today?
Yeah, so time series data is the most integral part, honestly, to getting predictive maintenance and just in general, in the development, in the DER space, it's very important to be able to use that data to figure out not only when things are going wrong, but also when they're going right. And you can't do that without having the data to back it up to an extent. You cannot say that your device is overheating if you don't know what the normal heat values are meant to be inside of it. As many people who work with IoT sensors know, that's some of the most integral parts of that data.
Now, in terms of InfluxDB, have you had any enhancements to the product or whatever recently?
Yeah, so one big enhancement is we have our new V3 engine. So it's built on columnar data store. And the big thing there is it involves a higher, we already were really good at high ingest rate to be honest, but we still have a great high ingest rate for high volumes of data. We have a great compression engine, which is very important for cost saving and overall storage. And we also offer cold storage options as well for our customers, which is a new thing that a lot of them have asked for many, many years. Because again, all this predictive maintenance, predictive analytics, you actually need your historical data to do it. Now that doesn't mean you're calling your historical data every single day. Of course not. You can cold storage it, and when you need it, it also doesn't need to be super fast either. It's not real-time monitoring, it's building your own, to an extent, it's just building your own analytics to know when things, your own anomaly detection, your own predictive maintenance, to know when things need to be addressed.
Now in the context of IoT and edge devices, how does your technology play into that?
Yeah, so we actually offer edge data replication built in. So because we have our open source and we have our cloud and we have our on-prem, we have edge data replication which takes your open source that can be run locally and it has a dispatch queue that will store the data until it has connectivity and then it will send it up to the cloud. So that helps a lot of people so they don't have to build that system themselves. So pretty much what you do is you just set up the stream, it's all built in, like I said. Now that being said, it's built in. So it only goes to Influx Cloud, you can't stream it somewhere else. But basically you have your open source running on any kind of device, and a lot of people will do this even on, even in places where you would think there would be good connectivity. Things like a factory floor in a major area, not like a city per se, but in an area where you would expect it to be connected. A power loss could be all it takes, that the factory's still online, but it's no longer connected to the internet, and so being able to have that dispatch queue is very important, all the way to our customers who actually have things that are very remote. They only connect once a day when the satellite comes overhead, and until then they're off-grid for all intents and purposes. And for them, edge data replication is really important to be able to store that data on the edge device and then stream it to the cloud.
Now here at Distributech, sustainability is also a key theme. How does this all play into a sustainability story? Yeah,
so without a doubt, a lot of, as most people would know, sustainability has become more of a thing in the past 20 years. So a lot of sustainable companies, that can be things like electric vehicles or, utility companies not so much, they've been around for a while, but in general, as they start to make their sustainability changes, whether you're a new technology or an old technology, you tend to want to use newer tech to an extent. You want to leave your older, data storage where it came from, and a lot of that older data storage also isn't interconnectable. It does not work with outside stuff. You're stuck within that ecosystem. We're not like that. We're an open ecosystem. You can use us with whatever analytics tooling you want, with whatever graphing tooling you want. You can send your data onward to whoever you want. That's the other big thing. It doesn't just have to be your office or your manufacturing floor or your substation. It does not have to stay in this small ecosystem. It can be very broad, which is extremely helpful for, you're dealing with a big state, for example. You can't just have your data just in South Florida or just in North Florida. You need a whole, holistic view. And that's, it scales obviously to things much bigger than that.
And one of the key themes here at the show so far has all been around DER and aggregators, virtual power plants, and sharing the data amongst many people.
Yeah, it's a very key feature to be able to share that data, especially because it used to be honest, data science wasn't really a job. Like it was a job, but not like nowadays. Now we have real data scientists who are really taking that data and doing all this cool work with it, and they demand it. They really, they really want this data off these companies. and all of a sudden the companies are going, we've been storing this data for 20 years, and it's in a hard drive. Good luck, and that's just not acceptable to a lot of people, and it doesn't work with the tooling they need to use as well. It's sad, but it's true. The Power BI doesn't accept a hard disk. You need a hard drive. You need to get it a little bit more modern to get it to intake your data.
Now, one question, if I may. You talk about real time. Real time means different things to different people. If you're in a SCADA system, if you're in smart meters, how do you define real time?
So personally, I always define real time as within the day. That's, for some reason, to me, that seems in real time. Now, obviously, for some of our customers, real time is down to the millisecond. It's real time. Like, I need to be staring at it right now. But for some of our customers, real time can be as fast as, like I said, it could be a day. For them, that can be a good enough range. I think a lot of people would define it as the past hour as well. But it's honestly dependent on the time scale of what you're dealing with. Again, somebody on a factory floor or staring at the device, they expect it. They're looking at it right now. It says 88 degrees. It better be 88 degrees. But the person who's looking at the data an hour from now is a little more like, yeah, it was around 88 degrees at like 5 p.m. They also don't look at it as in depth. They might even actually not even have it down to a minute scale, but more like 5-minute increments. They're looking at it over an hour and they see 6 data points. That's not quite as real time as I'm staring at it right now.
Well, as you say, it's down to the use case, and the use case will have defined what they see as real time and what works for them.
And for a lot of people, real time can also just mean fast. Honestly, that really can also be what it means to them. It's just, how fast can I get my data back? If it came in 1 second, it's real time. If it took 20 minutes, not so real time anymore.
No, I agreed. Hey, good stuff. Thank you very much.
Of course.